Example 43, we are looking for the derivative of x minus 4e to the x. These are nice, quick derivatives for us to find. All right, so we have the derivative of x, which is 1. We have a coefficient of -4, so we're going to keep that. And then we take the derivative of x, e to the x, which is e to the x. And that's it. We're done. We have our derivative there, 1 minus 4e to the x. For example 44, we have e to the opposite of x. So this is a chain rule situation. We don't have e to the x like we do in the other three examples. We have e to something else, e to an inner function. And in this case, the inner function is the opposite of x. Okay? So we have to use the chain rule. The chain rule says derive the outer function. The outer function is e. All right? What's the derivative of e? It's e. Right? Keep the inner function. So we're going to keep the opposite of x as our exponent. In essence, it doesn't really matter what the exponent is going to be. E to the whatever is always going to derive to e to the whatever. Okay? However, if we have something more than x here, then we have to follow the rules of the chain rule. And the chain rule says derive the outer, keep the inner, and then derive the inner. So now it's time to derive the inner function. The inner function is our exponent, so what's the derivative of the opposite of x? Yeah, it's -1. So we're going to multiply this whole thing by -1. Okay? And that -1 is down on the base level. It's not up in the exponent, it's down on the base level. So we could see our answer written in this regard, or we could move that -1 out front, and in which case we'd have the opposite of e to the opposite of x. Okay? But when you're dealing with the chain rule, e to the inner function will still derive to itself. Just make sure to multiply by the derivative of that inner function at the end. X times e to the x. Product rule, because we got ourselves a product. X times e to the x. So, derive the first, derivative of x is 1. Keep the second, e to the x, plus, now keep the first one, x, and derive the second, e to the x. There's our derivative. We use the product rule while also using e, just like we use the chain rule while also using e. One thing just quickly to keep in mind here, if this type of problem does come up on a multiple choice question, you probably won't see this as an answer. You will see a factored version of this. We have two terms, and e to the x is part of both terms, so we can see that being factored out, and the leftovers are 1 plus x. That would be most likely the type of answer you would see in a multiple choice question. And finally, example number 46, x squared divided by e to the x, quotient rule. All right, so here we go. Bottom d top minus top d bottom, and the derivative of e to the x is e to the x all over the denominator squared. There's your quotient rule in action.